In this previous video, we have learned about what is semantic analysis and syntax-directed translation. Let us make more clear by doing more problems. One is syntax-directed definition for a symbol calculator and another one is syntax-directed translation for symbol type declaration. We have We have already done what is SDD for symbol test calculator. Here L gives E. We know this grammar and we know what is this semantic actions. Now let us clear by practicing some input strings. For example, the input string is 5 plus 3 star 4. What we have to do first, we have to construct the parse tree. Then what we have to do, we have to traverse. When it comes here, we get the value of digit, and when it comes here, we get the value of f. Like this, we traverse the parse tree and we get the value 17. Now we are considering another example, 3 plus 4 into 5 plus 6. For First of all, we have to make the parse tree. For making this parse tree, we have to select appropriate productions from this given grammar. And we got a parse tree, and then we have to traverse the parse tree bottom up. Like this we have done. Here we got the value. Like this we are doing, and we got the value. Here is 7. T gets the value from F. Now we are going the right side of T. We got f dot value is equal to 11. Here this t gets the values from multiplying its left child value and right child value, that is 77, and we got a final answer 77. Now we are going to discuss about SDD for symbol type declaration. For example, int a. Another example is int a comma b comma c. So first of all, in type declaration, it starts with a data type, then followed by one or more number of identifiers. That is, declaration is equal to TL. This T can be int, real, float, unsigned int, etc. In this example, we have considered data types int and real. This L, what is L? L can be an identifier or a collection of identifiers. L gives ID. Now, for getting this kind of collection of identifiers, we have to iterate L. That is, L gives L1 dot L1 comma ID. Now we got the context free grammar. We have to design the semantic actions. First of all, let us start from here. This T has an attribute type. It gets its value integer from its child. Like here, T gets its value for attribute type as real. So from what is the data type of this A? Int. It gets its value from data type. So this L gets its value, attribute value from T. L inherits its value from its sibling. That is, L has an attribute in. L dot in is equal to T dot type. Here, what is the value of B? Value of B is same as value of int. That is, L1 dot inherited is equal to L dot inherited. And here we are doing some action, add entry. We are adding this entry along with this data type into symbol table. Here too we are adding the value of ID into the data type along with its data type. This is what we have discussed now. T gets its value from children. So T has a synthesized attribute type, and here L inherits its value. L is associated with semantic role L dot in is equal to T dot type. That is, L inherits its value from T, which set the in, that is L has an inherited attribute L dot in. The production L comma ID, here we are using this L and L1 to distinguish two occurrences of L. Now we consider annotated parse tree for an input int id comma id. What we have to do first, we have to construct the parse tree. After constructing the parse tree, we have to traverse the parse tree to perform semantic action. Here, from starting, we have traversed the parse tree and now we have reached t gives int. We have seen a production t gives int. Then we have to perform corresponding action. What is the corresponding action here? T dot type is equal to int. Now we are continuing our traversing and we have reached here. Now what we have to perform? We have to perform some action. That is L gets its value from its sibling T. Value obtained from sibling, that is L dot in is equal to int. Now we are continuing the traversing and here this L gets its value from its parent. This L This L gets its value from its parent L dot in, which is int. And we are continuing traversing like this. And now what we are doing here, we are putting an entry into the symbol table and we are continuing this traversing. Let's consider another example, real p comma q comma r. First of all, we have to construct the parse tree. Then we have to traverse the parse tree. When like this, we are traverse here. When we see a production, now we have seen a production t gives real. Then we have to perform semantic action. From here, it gives the value to L. This L inherits its value from its left sibling T. From L1 gets its value from its parent L, and here like this. Like this, we have considered the parse tree, we have traversed the parse tree and we got the annotated parse tree for this input.